Pull up any flight tracker right now. Look at the Airbus A320neo family aircraft crisscrossing the globe. You'll see thousands of them, the backbone of modern aviation, the most ordered single-aisle aircraft in history. What you won't see are the hundreds sitting idle on tarmacs across 3 continents. Not because airlines don't want to fly them, not because passengers aren't booking seats, because they literally cannot get engines. This isn't a minor supply hiccup, this is a systemic failure affecting one of aviation's most critical components. And most travelers have no idea it's happening. The Pratt Whitney GTF engine, the revolutionary powerplant that promised to transform fuel efficiency, has become the industry's most expensive headache. A microscopic manufacturing defect discovered in 2023 has cascaded into a crisis that was initially forecast to ground an average of 350 aircraft per year through 2026, but actual groundings peaked above 700. Airlines are losing thousands per day for every grounded jet. MRO shops that used to turn around engines in a matter of weeks now take 250 to 300 days. Leasing companies are cannibalizing brand new aircraft just to harvest their engines. There are 5 interconnected forces that created this crisis, and each one depends on the others. A powder metal contamination, a revolutionary engine design, a lean supply chain pushed to breaking point, a regulatory response that multiplied the problem, and an economic cascade that's reshaping airline economics worldwide. By the end of this video, you'll understand why a manufacturing defect smaller than a grain of sand can ground a multi-million aircraft, and why some aircraft are now worth less than the engines bolted to their wings. Let's start with the defect itself, a microscopic flaw that triggered aviation's biggest invisible crisis. In July 2023, RTX, the parent company of Pratt Whitney, disclosed something that sent shockwaves through the industry. A contamination defect had been discovered in the powder metal manufacturing process for high-pressure turbine and compressor discs in Pratt Whitney's PW1100G geared turbofan engines. These aren't minor components, they're the heart of the engine, spinning at thousands of RPM, experiencing extreme temperatures and pressures. A failure in these discs doesn't mean an engine shutdown, it means potential catastrophic uncontained failure. The contamination was traced to the powder metallurgy process used to create these critical rotating parts. Microscopic impurities had compromised the structural integrity of discs that needed to be absolutely flawless. Initially, RTX identified approximately 600 to 700 engines requiring removal and inspection between 2023 and 2026. The scope then expanded to encompass a fleet management plan covering engines manufactured during the affected period between late 2015 and the third quarter of 2021. But here's what makes this crisis different from typical aviation recalls. The PW1100G isn't just any engine, it's the powerplant for the Airbus A320neo, the single most important commercial aviation program in the world. Every grounded engine means a grounded aircraft. Every inspection slot consumed means another airline waiting. The math became brutal almost immediately. Airlines typically operate with a 5 to 10% spare engine buffer. The GTF crisis demanded 2 to 3 times that number. Spare engines that didn't exist, inspection capacity that wasn't built. And this defect wasn't something that could be fixed with a software update or a quick part swap. Every affected engine needed to come off the wing, go through a comprehensive inspection, and potentially undergo complete disc replacement. The domino effect had begun, but the powder metal defect was only the trigger. The real crisis emerged from what happened next. Understanding what happened requires understanding how aircraft engine maintenance actually works. When an engine needs inspection or overhaul, it goes to an MRO facility. Maintenance, repair, and overhaul. These aren't just big garages, they're highly specialized facilities with certified technicians, proprietary tooling, and regulatory approvals that take years to obtain. Before the crisis, a typical GTF engine shop visit was measured in weeks, routine enough. Airlines could plan around it. By 2024, those shop visits, they stretched to 250 to 300 days. Not because the work itself took longer, because every facility on the planet was overwhelmed simultaneously. Think about the supply chain requirements for a single engine inspection. You need the physical shop capacity, certified technicians with specific GTF training, replacement parts, some with lead times measured in months, regulatory paperwork, and traceable documentation, test cell time to verify repairs. Now, multiply that by thousands of engines, all needing attention within a compressed timeframe. The bottleneck cascaded everywhere. Shop capacity became a strategic asset. Airlines started competing not for aircraft or routes, but for inspection slots. Carriers with robust MRO contracts recovered faster. Lean operators found themselves stranded. Pratt Whitney scrambled to expand capacity. It grew its global MRO network. They developed the GTF Advantage, a new engine variant promising significantly improved durability and time on wing. Already certified by the FAA, separately, Pratt developed additive manufacturing repairs designed to cut processing times by over 60%. But building MRO capacity isn't like spinning up a new server farm. It takes years. Certification alone can consume months. Training technicians takes longer. The industry faced a simple, brutal reality. There was no quick fix. The infrastructure to handle this volume of engine work simply didn't exist and couldn't be created fast enough. So, what happened to the aircraft waiting for engines? That's where the crisis got truly strange. Wizz Air built its entire business model around the Airbus A320neo and its Pratt Whitney engines. The Hungarian ultra-low-cost carrier operates one of the most fuel-efficient fleets in Europe. Their A320neos were supposed to deliver 15 to 20% better fuel burn than previous generation aircraft. That efficiency was core to their competitive strategy. Instead, the GTF crisis has devastated their operations. As of Q3 FY25, Wizz Air reported operating loss of €123.9 million. An average of 33 aircraft were parked during quarter, equivalent to almost 13% of its fleet. The airline now expects A320neo groundings to continue for years to come. To cope, Wizz is maintaining a significantly expanded spare engine inventory. That's capital tied up in engines sitting on the ground instead of generating revenue. It is not alone. Spirit Airlines deferred Airbus deliveries and furloughed 260 pilots, citing in part engine issues. The delivery deferrals improved its liquidity, money it desperately needed because it couldn't fly aircraft it was paying for. The economics are stark. An aircraft on the ground costs thousands per day in lost revenue. Multiply that by hundreds of grounded aircraft across the global fleet, the industry-wide cost runs into billions annually. RTX itself recorded an approximately $3 billion charge from the recall and inspection program in 2023. For perspective, that's money that could have funded new engine development or expanded production capacity. The GTF crisis created winners and losers, and the competitive effects will reshape the industry for years. Compare the GTF situation to its main competitor, CFM's LEAP engine, used on both A320neo and Boeing 737 MAX aircraft. The LEAP has faced its own delays and challenges. Airlines locked into GTF-powered fleets found themselves at a massive competitive disadvantage. Carriers that had diversified their engine selections or chosen CFM exclusively could maintain schedules while competitors scrambled. The leasing market amplified these effects. Spare engine leasing rates surged 20 to 30% since 2019. Lessors who controlled GTF spare capacity gained enormous leverage. Some even began cannibalizing relatively young A320neos, stripping airframes for their engines because the power plant had become more valuable than the aircraft itself. Airbus's term, gliders, captured this inversion perfectly. A competitive aircraft minus engines was worth less than the engines alone. Looking forward, the competitive implications are significant. Airlines are reconsidering their fleet strategies. Pratt Whitney faces long-term reputation damage. The GTF's revolutionary geared architecture genuinely delivers 15 to 20% fuel efficiency improvements. But airlines now associate that innovation with operational chaos. Rebuilding trust will take years of flawless performance. Pratt & Whitney insists the situation is improving. The company projects the crisis will continue beyond 2026. Full normalization isn't expected until the end of the decade. Let that timeline sink in. A defect discovered in 2023 will affect operations until approximately 2030. 7 years of disruption from a manufacturing flaw. The recovery depends on several parallel efforts. New engine production must continue feeding Airbus assembly lines, while simultaneously building spare inventory. MRO capacity must expand through new facilities and improved processes. The GTF Advantage components must provide their reliability in service, and the supply chain for replacement parts must scale to meet unprecedented demand. None of this happens quickly. Certification, training, facility construction, these operate on timelines measured in years, not months. Meanwhile, Airbus is pushing ahead with production ambitions. It delivered 607 A320neo family aircraft in 2025, with the A321neo comprising the majority of deliveries, indicating strong demand for the larger narrowbody variant despite engine troubles. Market demand remains robust. Airlines still want these aircraft, they're just not sure they can actually operate them reliably. Not every airline dependent on GTF engines has suffered equally. Carriers with robust MRO contracts and diversified spare pools recovered faster. Some operators accelerated fleet transitions, using the crisis as justification to exit older GTF variants earlier than planned. Others deferred new deliveries, preserving capital until the supply chain stabilizes. And the crisis has prompted industry-wide reassessment of lean operating principles. The 5 to 10% spare engine buffer that was industry standard looks dangerously thin in retrospect. Airlines that maintained larger reserves, absorbing the carrying cost of idle engines, found themselves at an operational advantage when the crisis hit. Future fleet planning will incorporate supply chain resilience as a factor, alongside traditional metrics like fuel efficiency and seat mile costs. The cheapest aircraft on paper isn't cheap if it spends months waiting for engine parts. These adjustments represent lessons learned, but they also represent costs that ultimately flow through to ticket prices and airline profitability. Step back and see what's actually happening here. Every day, thousands of A320neo aircraft operate globally. They carry millions of passengers. They form the backbone of short and medium-haul aviation on every continent. And yet, hundreds of their siblings sit idle, grounded by an invisible crisis that most travelers never notice. The GTF engine shortage reveals something fundamental about modern aviation. The visible aircraft represents only the surface of an extraordinarily complex system. Beneath it lies a web of manufacturing, certification, maintenance, and logistics that must function flawlessly for planes to fly. A microscopic contamination in powder metallurgy triggered a cascade, affecting assembly lines in France and Germany, maintenance facilities across 20 countries, airline operations on 6 continents, and financial statements in dozens of corporate headquarters. This pattern evolved because the industry optimized for efficiency over resilience. Just-in-time manufacturing, lean spare inventories, single-source suppliers for critical components. Those choices made aviation cheaper and more efficient until they didn't. The engine shortage that's secretly grounding modern aviation isn't really about engines at all. It's about what happens when a system designed for perfection encounters reality. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?